So a permutation of a set of distinct objects is an ordered arrangement of these objects. Okay, so before I do this example, I want to focus in on this term ordered, because it's super important. Okay, it's an ordered arrangement as opposed to something something called a combination we're going to see a little later where it's not ordered. But I want you to write this down somewhere, and I want you to remember it. So when you're doing a permutation, two things. No repetition, that is, you cannot choose an object more than once. So there's no repetition, and the order you choose them in matters. So think about that example that I did with the table. What I was doing was an ordered arrangement of the 5 objects on that table, because choosing out the spool of thread first is different from choosing the the He-Man action figure first. So those would be 2 different arrangements. So what we did, we actually did a permutation of objects in that previous example, and I don't remember what the order was, what order I chose them in. But if I had, chose the switch first, that would have been a different arrangement, so a different permutation than the one that I did in that example. So we can also do this with sets. So if I want to look at all of the permutations of the set ABC, so what I want to do is figure out the different ways I can arrange the letters A, B, C, where the order matters. So I could, first of all, I could just have A, B, C, that's one permutation. Or I could have A, C, B, that's different because the B and the C, the orders are swapped. Or I could have B, A, C, I could have B, C, A, I could have C, A, B, or I could have C, B, A. And that's all of them. This is all of the different ways to arrange that. Now, I know that's all of them because, I was very systematic in the order that I wrote them down in. However, there are 3 objects there. And if you think about this as the number of ways you can choose them, I have 3 choices for whichever one I pick first. Once that one is gone, I have 2 choices for the second one I pick, and then 1 choice for the last one I pick. So that is 3 factorial, which is equal to 6. It's exactly the same thing that I did with the table full of random objects. It's just 3 factorial in this case, 5 factorial in this case. So the permutations of n objects would be n factorial. Now, you don't have to choose everything in a set when you're doing a permutation. Think about if I had that table and I wanted to count the number of ways that I could just choose 2 of them. That's what this next little bit is going to be about. So n is a positive integer, and r is an integer that's in between 1 and n. When that's the case, there are p parentheses n comma r, and this is permutations of n objects r at a time. And this is called r permutations of a set with n distinct elements, or permutations of n objects r at a time. And the way you calculate that is n times n minus 1 times n minus 2 down to n minus r plus 1. Now, I know this can look a little bit confusing, but in practice, it's really easy. So let me show you an example. So what I have here is a set with 4 elements. So n is equal to 4, and I'm choosing 2 of them, so r is equal to 2. So what I'm doing is I'm counting permutations of 4 objects taken 2 at a time. Well, if I follow the definition up there, it's going to be 4, and then look what happens. I just keep going down. N times n minus 1 times n minus 2, so I would have 4 times 3. And when do I stop? Well, I stop when I get down to n minus r plus 1. N is 4, minus r would be 2, plus 1 would be 3, so I stop. So it's just 4 times 3. So that is equal to 12. So there are 12 different ways to choose 2 objects from that original set of 4 objects. So you stop counting down on multiplication when you get one more than r. Okay. Let me show you another formula that I believe it's in the book, but sometimes people find this one just a little bit easier. Another formula for permutations is this. Permutations of n objects r at a time is equal to n minus r factorial. Whoops, nope, that's wrong. Let me erase that. It is n factorial divided by n minus r factorial. Okay, so if I want to use this formula, I would have permutations of 4 objects taken 2 at a time. I have 4 factorial over 4 minus 2 factorial. And I'm going to show you a little trick you can use if you don't happen to have your calculator. And by the way, I will show you how to use your calculator to calculate permutations with big numbers. There's a permutation function on your calculator that you can always use. But watch this. 4 factorial is equal to 4 times 3 times 2 times 1. 4 minus 2 is 2 factorial. So that's 2 times 1. So like 2 times 1 cancels with 2 times 1 down here, which just leaves a 4 times a 3. So you can always do this little trick. You'll always be able to use the bottom factorial to cancel out a lot, or at least some, of the numbers that are on top. So whenever you're doing this calculation, you'll always be able to do that. And again, I'll show you in class how to use your calculator to do this.